All right, so we are going to be going into our excretory system. And when we look at the excretory system, we're really talking about all the ways that the body is able to remove waste. And that would include every time you guys exhale and get rid of your gas waste through carbon dioxide. When you sweat and you are getting rid of that waste product through your skin, that is also considered excretion. When you remove solid waste from the body, that is also an excretory function. But when we get down to the actual chapter and covering the information, we tend to focus primarily on the urinary system. And the reason for that is that when we go through other chapters, we tend to cover those other functions of how we excrete waste product. So we do the integumentary system and we talk about sweat there. We do the respiratory system, so we get rid of the carbon dioxide, or we talk about it there. And then when we do the digestive system, we talk about the solid waste removal, which leaves us, by the time we actually get to the excretory system, only really needing to talk about what happens with our liquid waste. So a lot of times when you hear about this or you move through anatomy and physiology, it is just referred to as the urinary system for that reason. So please understand that when we talk about the 11 body systems, the excretory system is one of the 11, and that encompasses all the ways that the body does remove waste. So right now we're just isolating it, and that's the reason of how we actually got here. When we look at the urinary system, people know that we void liquid waste from the body multiple times a day. Typically for the average person, you're looking at about 6 times. And I say average, some people are going to be above that, some people will be below that. And there are a lot of things that factor into that. But the urinary system is going to do a lot more. And those are listed in that first slide for you. So we're looking at maintaining homeostasis. In removing liquid waste from your body, you are getting rid of different ions and other materials that would impact your sodium balance, that would impact your pH level. And so it's very important that when we remove waste, it's not just about getting excess water out of the body. There is a lot more to it than that. It is a constant function that is monitored by the brain, because if your salt levels are too high, if your pH levels are off, if ion composition is not where it needs to be, then the brain has to figure out what it needs to tell the kidneys, what they need to pull back and pull into your body and hold on to, or what they need to continue to force out through that liquid waste. So it is very much a balancing act, and it is something that is monitored 24 hours a day, 7 days a week. It's not just simply you drink a lot of water and now you have to get it out of your system. It's about making sure that a lot of different elements, a lot of different ions, and like I said, that all important pH level is getting maintained and held where it needs to be. When we talk about the excretory system also, you will hear a lot about things like acidosis and alkalosis, and that ties into those pH levels. So when you have somebody who is in metabolic acidosis, that what they're telling you is that their pH level is starting to swing into the acidic side of the pH balance. So where we want that pH for the human body to be at 7.4, now we're starting to creep closer to 0 and lower numbers. If you are in alkalosis, now we're swinging from that 7.4 and we're moving up towards that 14 level. Remember, pH level has the smallest amount of swing. So you can only vary from your pH level a very small degree before it actually starts having a very large impact in the body and how it functions. The second point on there kind of already covered that you are removing waste product from the body. And so your urinary system is going to be one of your filter systems that the body has. 3 major filter systems: the liver, the kidneys, and the spleen. So the liver typically is going to take care of those things that are toxic and come in from outside the body. The kidneys are typically going to take care of those things that are from inside the body. And then your spleen is going to get those foreign invaders, so viruses, bacteria, things that could potentially cause harm to your body. The last point that you have on there talks about the major parts, and really you don't have a whole lot of parts, but they are very intricate for the parts that you do have. So you have the kidneys, should have 2 of those. You have your ureters, which are going to extend from the kidneys down to the bladder. You have the bladder itself, which is made out of transitional epithelium, meaning that it can stretch. When it's not in use, it's very, very small. And as it fills with liquid, it has the capability to expand and accommodate that liquid that it's taking on. And then we have the urethra, which is going to take the urine from the bladder to the outside world. If you look at the second image that we have there, shows you a picture of all of the structures and how they're positioned in relationship to each other. So some important things that you have here. Number one, if you look at the position of the kidneys in relationship to the rib cage, you'll notice that they do get some protection from the ribs, but they are not fully encased by the ribs. The bottom half of your kidney is going to be exposed, and so they don't have that bone protection. So top half gets that, lower half is a little bit more exposed. And that is part of the reason why your kidneys are encased in a capsule of fat, because that is trying to help take over what the kidneys don't get from not having full bone protection. You can also see the adrenal glands, the 2 little cream colored structures that are sitting on top of the kidneys. Those are going to be the glands that would introduce adrenaline into your body. And heard me say it 100 times, nothing in the body happens by chance. So the positioning of those adrenal glands is very strategic in the fact that in times of stress, they will dump that adrenaline into your kidneys. And because of how much your kidneys filter the blood and how much access they have to the blood, you can disperse that adrenaline into your bloodstream in a very short period of time and then get that to the rest of the body in a very quick manner as well. You can see the red and blue blood vessels running in and out of the kidneys, and those are going to obviously bring the blood in to be cleaned and then bring it back out once it has been filtered. You get a view of the ureters that extend from the medial side of the kidneys down to the bladder. Not crazy about this picture because it makes it look like the urethra, or excuse me, the ureters go into the top of the bladder. They do not. They actually will take a little bit of a turn and they go to the back side of the bladder, and they will actually filter the urine into the bladder a little bit on the posterior side. It is not directly from the top as it would indicate or look like from this particular picture. And then the urethra kind of gets cut off in this picture, and that's a structure that we'll talk about a little bit more later. So we'll come back to that. If you look at the information that's provided, it indicates that your kidneys are not on point with each other. And if you look at that, you can see that the left kidney is going to be a little bit higher than the right side one. And the reason for that is because of the positioning of the liver. The liver is the largest internal organ that you guys have. And because of the size of the liver, it's actually wide on the lateral side of the body, and then it tapers as it comes across to the middle of the body. And so because of that shape of the liver, that kidney has to swing down just a little bit to make sure that the liver has the room that it needs in order to fully do its job. So like I said, they're a little bit offset from each other, and that's the reason why. Kidney, you can find the dimensions for the kidneys, and typically if you just ball up your fist and look at the size of your fist, that's going to be pretty on point with the size of your kidney. So they do vary a little bit from one person to the next, and if you just look at your fist, give you a pretty good idea of what your kidneys look like inside of your body. So if you move to the internal anatomy of the kidney and looking at this particular set, you can see the kidney has been cross-sectioned, so it's been cut in half, opened up, and you are now looking at the internal structures of the kidney. And when we used to get to do dissections, one of the reasons that we did the cat dissection, some people weren't crazy about doing the cats, but we got to a kidney that was large enough that when you opened it up, you could actually see all of these internal structures. Some of the other things that we dissected, fetal pigs, you can see the kidney, you can cut it open, but you really don't get to see the structures because it's just not large enough or developed enough to be able to give you that look. So that's what the inside of the kidney would look like. And you have quite a bit going on within the kidney. So I'm going to take you through those structures, what they do, and how it all kind of comes together. So starting with the renal capsule. And again, with this particular picture, they are leaving out the fat. If you were to open somebody up and look for their kidney, a lot of times the kidney is mistaken for a tumor because it is a mass that is found. It's called retroperitoneal. That means it's outside of the abdominal cavity. Retro tells you it's behind, so it's literally telling you it is behind the abdominal cavity. And when you look for the kidneys, they are completely encased in fat. So you have this yellowish material covering the kidney. It just kind of looks like this weird mass. And like I said, a lot of people, when they first go looking for it, will tell you they found a tumor in the back of their cat or whatever they're dissecting. And what they have found is that fat capsule that is there to protect the kidney. Once you get into that, you'll see the renal capsule. And the capsule is very important. It's a tough material that you have over the surface of the kidney. And the reason that it's so important is because if you think about what the kidney has to do, this is filtering out material from your bloodstream that, if it was allowed to build up in your body, would do damage to your body. This is stuff that would throw your ion balance out of whack. It would throw your pH level off balance. It would interrupt chemical reactions that would be essential for life. And so once these things are filtered out of your body, it is very important that they are kept inside that kidney until they can be eliminated from your body. So that capsule is very thick, durable material, encases the entire kidney to make sure that once that's been filtered out, it cannot diffuse or leach back into the surrounding tissue and get back into your system. From there, you have the renal cortex and the renal medulla. Renal is going to indicate kidney. So anytime you see renal, you know we're talking about the kidney in some way, shape, or form. And they're just talking about the two layers. So the very outer layer of the kidney would be the cortex. There's a little bracket there that indicates that section. And that would go all the way around the outside ridge of the kidney. And then the next layer down would be the renal medulla. And again, you have a bracket there that shows you that particular layer. If you look a little bit to the right-hand side, they've got that pull-out picture, and I think it does a little bit better job of showing you where that renal cortex and that renal medulla is actually located. Now, from there, you have a variety of structures that are in your kidney, and I'm not going to necessarily follow how they have them labeled. I'm going to kind of work from the outside and work my way in, because at this point what we're doing is we are filtering the blood. So you have the renal artery and the renal vein, which are going to bring the blood in and out of the kidney. And once they bring the blood into the kidney, they are going to get delivered to those tiny little yellow structures that you can see. And those tiny little yellow structures are called the nephrons. The nephrons are the smallest working unit that you have within the kidney. So this is true in pretty much everything we've talked about. Talk about life, smallest unit is the cell. You talk about the sarcomere, that's the smallest unit of the muscle. When we get into the kidneys, the smallest working unit is the nephron. So as that blood is brought into the kidney, pretty much the first stop it's going to make is in that nephron. And the nephron is going to begin the process of filtering out that blood. Once it's filtered out the material from the blood, and this is pretty much a clean sweep at the start. So the only thing that really remains in the blood are your blood proteins, your red blood cells, a few other materials, but pretty much everything else is going to get cleaned out initially. And once that happens, that material will get filtered through. The body will determine, as it makes its way through the nephron, what needs to remain out and not go back to your body, and what is okay to be reused and recycled. And after that division and that separation is made, whatever remains in the nephron is now going to become part of your urine and get removed from the body. Blood vessels are right there, so anything that is deemed to be reusable will now get pushed back into your bloodstream, recycled, and sent back for your body to use. So it allows for your body to be very efficient, but also make sure that pretty much everything is getting cleaned out of that blood. Once the material has been pulled and it's been determined that it needs to leave the body, where it's going to go from that nephron is now into the renal pyramid. And renal pyramid is the second one from the bottom. So like I said, I'm not going in order with the list. But if you look around the kidney, you'll notice typically you have between 8 and 12 renal pyramids that will fan out around the inside of the kidney. And the renal pyramids are really going to be a funnel. And there's a lot of new terms as we go through this, but honestly, all that you have going on is you are funneling that urine from one part of the kidney to the next, until you ultimately get it out of the kidney. So when we look at all of these terms, I want you to think funnel. So the renal pyramid is going to collect any of that material, it's called filtrate, from the nephron, and it's going to start the funneling process. So the renal pyramid is going to take that material, that filtrate, and if you will find the minor calyx, excuse me, the minor calyx is a structure that is going to come right off of the renal pyramid. So renal pyramid into the minor calyx. And then you'll notice if you look at the minor calyx from one renal pyramid, and then you look at the one from the neighboring one, and so on and so forth, that all the minor calyces fuse together. So when those minor calyces fuse into a larger funnel, now we call that a major calyx. So a bunch of little ones come together, they go from being a minor to a major. All we're doing is funneling the filtrate forward. So it goes renal pyramid into the minor calyx into a major calyx, and we are keeping that urine moving forward so that we can get it out of the kidney. So from there, as we continue to move forward, the major calyces are again going to fuse, and they will fuse and come together and make what is known as the renal pelvis. So if you find the renal pelvis, again, we're just taking those funnels and fusing them together, but it's all in an effort to transition and keep that urine moving out of the kidney. From the renal pelvis, it is eventually going to make its way into the ureter. And you'll notice that ureter is going to then take a downward turn and start to make its way to the bladder. One of the most important things to understand about the formation of urine is that it's not like running water out of a faucet. The collection of urine is honestly a drop by drop process. So when we look at this urine being formed, if you think about those nephrons, you have over 1 million nephrons in a single kidney. And if you look at your hand, balled up fist, and that's about the size of your kidney, those nephrons are only in that outer layer. So they are incredibly small, 1 million of them packed in there, even though they are producing this filtrate, which is going to ultimately make your urine. It's very, very small amounts of liquid. So even by the time we funnel all of that together, get it to the ureter, it's small droplets of liquid. And so it's like a leaky faucet. One drop at a time is pretty much coming out of that ureter and being transferred down to the bladder itself. Very slow process. Now, a couple of the ones that we didn't talk about, you have the renal columns. And if you look and find the renal columns, not really fancy. They don't do anything except for they are support columns. So they are layers of tissue that you have built up between the renal pyramids, and they just make sure that those renal pyramids hold their shape, hold their position, and they don't collapse. So nothing really as far as producing urine or helping with that process. They're more support structures that you have there. You also have what is known as the renal papillae. It's right above the renal pyramid. You are looking for it. The renal papillae is going to be where the renal pyramid and the minor calyx come together. So where those two structures actually fuse and unite with each other, that point of those two structures coming together is just simply known as the renal papillae. So that kind of takes you through the major structures that you have within the kidney itself. I didn't mention the renal sinus, but if you find the renal sinus, it's kind of in the core or in the middle of everything. And that's essentially just indicating that core that you have within the middle of the kidney. From there, if you go to the next slide, it shows you the kidneys side by side, the aorta, you have the inferior vena cava there, just again, giving you an idea of how everything is positioned in relationship to everything. You have the kidney on the left side of the page, which is what it would look like from the outside. And then you have the kidney on the right-hand side, which is indicating what it would look like if you cut it open and did a cross-section. From there, we have the slide that indicates what the kidneys do for the body. Pretty much a repeat of the opening slide. So if you'll move down into the nephrons. Now, I already introduced the nephrons a little bit. There's no way around it. If you're talking about the internal structures of the kidneys, you have to talk about the nephrons. And when we look at the nephron, one of the biggest things that I worry about is that people are going to look at it and get overwhelmed. Don't get overwhelmed. There is a lot going on within the nephron, but it's honestly very easy if you just kind of deconstruct it and look at it in smaller parts than trying to take it in all at once. So within the nephron, essentially what you have, as I already mentioned, is a filter system. So this is going to clean the blood out and make sure that everything is getting processed, pretty much everything, so that you are not circulating things to your body that could potentially cause harm or damage. Remember, your blood is going to every single cell of the body. So as it makes its way through the body, from heart all the way back to the heart, it is coming in contact with all the cells of your body. If it's carrying something that is potentially harmful, you now are possibly going to deliver that to one of your cells, and now you could have all sorts of issues going on. So the nephron is put in place to make sure that we are cleaning out that blood and we are not delivering that harmful material to our body or letting it circulate over and over again. Again, I didn't mention it before, but if you think about where the kidneys are located in the body, they are pretty much dead center. So mid to lower back, if you think about where they were in relationship to that rib cage, they are about equidistant from the top of your body as they are to the bottom. And that's to make sure that if you do get something in your system that's not supposed to be there, it is going to spend the least amount of time in your body before it ends up in the kidneys and gets filtered out. So you can reduce how many cells are getting exposed to that material before it gets cleaned out of your system. If you'll actually go to the slide that shows the entire nephron structure itself. So it does not have a title heading on it. It just starts out with afferent and efferent. If you will take a look at that one, this is where I want to spend a couple of minutes. And like I said, when you initially look at this, can look a little bit intimidating just because of, sorry, I'm checking my time. It can look a little bit intimidating just because of the fact that you have all of these structures that are crisscrossing, going back and forth. And how are you ever supposed to keep track of what is going where? You don't have to. And if you are trying to do that, don't. Okay. You've got 3 colors. Focus on the 3 colors. Okay. So, well, kind of 4. You have the brownish tones, which are your tubules. Anything that is in one of those brown tubes, it's leaving the body. If it's in a brown tube, it's leaving. Your reds, that is an artery. So that gives you information about the type of blood that it is carrying. Blue is going to be your veins. again, gives you a lot of information. Oxygen level, direction the blood flow is going, all sorts of stuff. You have the purples in there, that's showing you your capillaries. So if it's a color, red, blue, or purple, it's a blood vessel. If it is in one of those three, it is staying in the body. If it's in the brown tube, it's leaving. Now, there are a couple of things that we need to talk about. Starting with the terms afferent and efferent. Afferent is a fancy way to say that you are moving towards something. Efferent is a fancy way of saying you are moving away. When we talked about our nervous system, we talked about our afferent and efferent nerve impulses. I told you guys it would come up again, so here we're seeing it again. But afferent and efferent, very fancy way to indicate direction. That's it. Now, when we look at the nephron, we're going to start with the glomerulus. So if you look right in the center of this nephron structure, you'll see that glomerulus. And what it is, it's fan-shaped collection of small blood vessels. So you can see that fan-shaped structure. It's got a little capsule sitting around it, the glomerular capsule. Excuse me. And what happens is the blood comes in to the nephron. And when it comes into that nephron, first thing that's going to happen within that capsule is that blood is going to be put through some pressure and it's going to force out pretty much everything. Blood proteins, red blood cells, a couple other things will stay behind, but everything else in the blood, water content, sugar content, other ions are going to get forced out. And you'll notice that out of the backside of the glomerular capsule, there's a tube that leads away. That is going to collect all of that material and start funneling it away from the glomerulus. Any of that material that it catches is called filtrate. Now, don't try and track the tube. Don't try and follow it. Okay. But eventually, you'll notice that there's a very large swooping brown tube that goes down, makes a big kind of U shape. That's where I want your eyes to go next. You'll notice that that's referred to as the nephron loop, and you have a descending and an ascending limb. Look at the size of that tube close to the glomerulus, the brown tube close to the glomerulus. And then look at the size of the tube in that descending loop. What happens to the size? It gets much smaller. So if I'm holding a sponge full of water and I clamp my hand down on that sponge, I'm essentially doing what that diameter size change is doing when we get into that nephron loop. It is increasing the amount of pressure that is being exerted on that blood. This is where the filtration process begins. So anything that I want to go back into the bloodstream, I know that looks like a crazy mess of blood vessels crisscrossing back and forth over that nephron loop. All they're there to do is catch whatever that nephron kicks out. So during that downward swing, we have two very important things happen. Number one, the size of that tube gets much smaller, meaning the pressure goes up, forces material out of the nephron loop. The blood vessels are there to catch it. So this is anything that the bodies can reuse is going to get transferred back into those blood vessels. We take it back to the body and we reuse it. Anything that is going to be eliminated from the body is going to remain in those tubes. Now, the other thing that happens is you see a very sharp turn. So it's a U shape, very sharp turn and then swings back up. Nothing happens by chance. So if we have this very weird shaped structure, there's a reason for it. And I always tell people when they look at this, think about if you were in a car and this was a road and you're driving on this road and it makes that sharp turn. You're going 65 when you come up on that turn. You're probably not going 65 when you actually go into the turn. I know some of you might say you would, but for most people, they're going to hit the brakes and slow down. The perk of that inside your body, blood flow slows down. If we're trying to look at all of this stuff that we've filtered out and make sure that we're pulling out all of the stuff we can reuse and we are leaving this bad stuff in to be eliminated from the body, you want to make sure that that gets done well. So by slowing down the blood flow as it goes through that sharp turn, that is the body's way of going through that very detailed, making sure that we get that process done very well and that we get a good separation of what can be reused and what needs to be eliminated. Swing back into the ascending loop, tube gets wider again, and now anything that is still in that brown tube is exiting. It is leaving the body, has no chance to come back in. So it goes into that collecting tube that you see there, and that is going to eventually lead down into all of those other structures we talked about inside the kidney and leave the body. Just checking my time. All right. The next slide down from there just kind of tracks how that would all go through that nephron structure. I don't expect you to commit that to memory by any means. And then we're going to stop here. I'm kind of getting on the high side as far as time goes. So I'm going to stop this one and we will come back and talk about how urine is formed a little bit later.